Hey y'all, in this video, I'm going to show you how to conduct a dependent or a paired samples t-test in Jamovi. I have different videos on testing assumptions and writing out the results. This is just conducting the test. And so this is the research question I'm going to use for the example. Will students score higher on a statistics intervention or statistics test after a meme intervention than they did before the intervention? So with a dependent samples or a paired samples t-test, the intention is to look at the pairs of scores. So in this example, I have students take the same or similar statistics test twice. And so that's actually my dependent variable. So I have this continuous variable that's the dependent variable, it's the statistics test. And my independent variable is actually time. That's what we're going to be looking at to see if there's a difference. We're looking to see if there's a difference after the intervention versus before the intervention. So those are our two related groups in this example. And that's often what you'll do in a dependent or a paired samples t-test is you'll look at the same measurement twice for the same people. So you might do this for a within subjects experimental design with two conditions. Or something like this where you do a pre-test and post-test. But again, you have these related groups, and they're related because the scores, the pairs of scores that we're looking at are coming from the same person. So I'm going to switch over to the Jamovi data set so that we can conduct this test. And what I will do there is go through the test again, and then I'll have a separate place where we can talk about the results. So here we are in the Jamovi dataset. And remember that each row is a participant, most usually. There could be exceptions, but typically what we're talking about is each row is a person or is a series of scores from the same person. So this one, we're looking at this pre-test for statistics and the post-test. So I have here the pre-stats test and the post-stats test. It's the same, we're measuring the same thing, we're just doing it twice. And so again, I'm looking at the pair of scores for this person, and we can see that their score increased to the post-test. This person decreased. This person decreased. This person stayed the same. This person went way down. Something must have been going on. And so we're looking at these scores and we're trying to see overall, are we finding that there's a change? And in specific, we're looking for the score to increase. So we think that our post statistics score is going to be higher. So the way we test that is we go to t-test. And we're going to choose t-test. We're going to do a paired samples t-test. And we only have two time measurements. So that's why this is appropriate for a paired samples t-test. And I'm going to move both of my continuous variables here. And again, it's the same variable measured twice. So I'm going to move my pre-stats first and then my post-stats here. Now, the way that this is set up, this is the basic setup. So we have the information if we were to leave this as a two-tailed test where we're looking for any difference. However, the research question we have is asking if the scores are going to increase after the meme intervention. So my expectation is that score one, time one, is going to be lower. That's what I'm looking to find support for. So I'm going to go down here to hypothesis, and I can see measure one is smaller than measure two right here. That's what I'm looking to see. I'm looking to see if measure one had lower scores than measure two, because measure two is the post score, and I would expect that to be higher if this meme worked, meme intervention worked. And then you can see this reflected here in the alternative hypothesis. The way that this works for the dependent samples is it's showing you measure one minus measure two because it does that for each pair. So that's why it looks different than the independent samples t-test. But it is showing the same information. If we subtract measure two from measure one, and as we put in this hypothesis, measure one is smaller, we're going to get a negative number. And so that would be less than zero. So that's how that matches together. The other information that we would want to get would be the mean difference, the confidence interval around the mean difference. You might not need all of this, but for my classes, you typically do, and the effect size and descriptives. So that's how you conduct that test in Jamovi. And then The next test, I'm going to talk about checking assumptions or the next video, I'll talk about checking assumptions, but this video I'm going to end here, and then I will see you soon.